All right, so this video is about finding the probability of events when they're overlapping or if they're mutually exclusive. Mutually exclusive. Okay, this video is about finding the probability of events if they're overlapping events or if they're mutually exclusive events. So let's talk about this. All right, so the first example says you randomly choose a card from a standard deck of 52 cards. What is the probability of choosing a king or a queen? So if that's true, in a deck of 52 cards, there's a king of hearts, there's a king of diamonds, there's a king of clubs, and there's a king of spades. Right? That's what they are. So there's 4 kings out of the deck of 52, and there's a queen of all those too. There's a queen of hearts and a queen of diamonds and a queen of clubs and a queen of spades. So that's 4 out of 52 as well. So if you want to find this probability, basically this probability are 2 events that are mutually exclusive. Like you can't pull out a card that's both a king and a queen. No card is going to be a king and a queen. So there's nothing that overlaps in each of those sets. So basically, you're going to add those up. It's going to be 8 out of 52, which reduces to be 4 out of 26, which is 2 out of 13. So it's 2 out of 13 chance. The reason why I know that's a formula, because these are mutually exclusive events. The formula for those is probability of A or B is equal to the probability of A plus the probability of B. That's a formula for mutually exclusive events, like if they don't overlap. So I basically took the first probability, 4 out of 52, add the second probability, 4 out of 52, and got those numbers. All right, let's look at a different example, one that they do overlap. All right, so in this next example, it says you randomly choose a card from a standard deck of 52 playing cards. What is the probability of choosing a heart or a 2? So if you think about this, these events, you do have a card in there that is a 2 of hearts. You do have a 2 of hearts somewhere in the deck. So you can't have a heart and a 2 be the same card. So for that matter, it's a different formula. These are not mutually exclusive. These are overlapping events. So these events are overlapping. How you find the probability there is you basically find the probability of the first thing or the second thing. If they're overlapping events, the formula should be the probability of the first thing plus the probability of the second thing. Take away the probability of all the ones that are the same. So probability of A and B happening at the same time. So this is what we're looking at. This is the formula we're using. So the first thing we want to find is, the first thing in this problem is a probability of being a heart or, so what comes after or is a 2. So you have to be a heart or a 2. So the first thing we want is the probability of getting a heart. And we're going to add to that the probability of getting a 2. Then we're going to take away the probability of being a heart and a 2. So if that's true, in a deck of 52 cards, there's 4 suits. So again, the suits are hearts, diamonds, clubs, and spades. And basically it's 12 cards each of those sets. Let me make sure I'm right though. You got a king, queen, jack, an ace. And then you have 10, 9, 8, 7, 6, 5, 4, 3, 2. So that's true. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You got 13 cards in each one of those decks. So that's true. The probability of getting a heart is 13 out of 52 cards are a heart. And then add to that probability of being a 2. So in each of those suits, you got a 2 of hearts, 2 of diamonds, a 2 of clubs, 2 of spades. So you got 4 2s. So if that's true, you got 4 out of 52 chance of being a 2. We're going to take away the probability of being a heart and a 2. So there's only 1 2 of hearts. So that's going to be 1 out of 52. So when you add all those together, it's going to be 13 plus 4 is 17, take away 1. So the answer should be 16 out of 52. So that reduces to be 8 out of 26, which reduces to be 4 out of 13. So the answer to that problem is either 16 out of 52, or even better, 4 out of 13. So that's how you find the probability of events if they're overlapping or if they're mutually exclusive. If you think you got it, we're good to go. I'll give one more example, though, just to make sure. All right, so this example says Missy rolls a 6-sided die. What is the probability of Misty rolling a 1 or an even number? So a die is singular for dice. So this is what a die looks like. You got one number that's 1, then you got another one that's 2, and then you got another one that's 3 or 4. Anyway, it's a dice. It's just one of them. So on that, you got 6 sides to it. And it says, what is the probability of rolling a 1 or even? So that's the probability of a 1 or an even number. And again, using the formula, the probability of A or B. Let's think about this. Is this mutually exclusive or is it overlapping? Like, are there any even numbers that's also the number 1? Well, there's no even numbers that's also number 1. So these are not overlapping events. There are no numbers that fit in both sections, both categories. So this is a mutually exclusive event. So it's probability of A plus probability of B. So that's a probability of rolling a 1 and plus the probability of rolling an even. So probability of rolling a 1 is 1 out of 6. There's only one number that's 1 on the back of a dice, on the side of a dice. And the other one is probability of being even. So on a die, you have 1, 2, 3, 4, 5, and 6. And the even ones are 2 and 4 and 6. So that's 3 out of 6 of those numbers are even. So that's 3 out of 6. So you add that out, that gives you 4 out of 6. Or better yet, 2/3. So there's a 2/3 chance that you can roll a 1 or even number. Anyway, all right, let's do one more. It says Ricardo spins a spinner that has 5 equal sections. So I guess a spinner looks like this. So you got 1, 2, 3, 1, 2, 3, 4. You got 5 equal sections. So it says 5 equal section number 1 through 5. So there's 1, 2, 3, 4, and 5. That's example what we're working with. And what is the probability of Ricardo landing on 4 or a number greater than 2? So let's think about this. So we got the numbers 1, 2, 3, 4, and 5. We want to land on 4, or we can land on a number greater than 2. So that could be 3, 4, or 5. So in this case, we have overlapping events. The 4 exists in both sets. So these are not mutually exclusive. These are overlapping events. So the probability should be probability of A or B should be the probability of A plus the probability of B. Take away the probability of A and B. We'll take away the overlapping part because you don't want to count it twice. That's why we take it away. So that's true. The probability of, so this probability of being a 4 plus a probability of being greater than, so this is greater than 2. Take away the probability of being 4 and greater than 2. So if that's true, the probability of getting a 4 is 1 out of 5 of those numbers. So it's 1 out of 5 are the number 4. Probability of being greater than 2 is 3 out of those numbers. So that's a 3 out of 5 of those numbers are greater than 2. And we're going to take away the one that overlaps, and that's just the number 4. So it's going to be 1 out of 5 here. So that's true. These 1 out of 5s cancel each other out, basically. Give you just 3 out of 5. So probability of both of those things happening in that overlapping event is 3 out of 5. That's all I have. Good luck.